Oink. Oh, hello. Welcome back for another awesome video. Woohoo! Woof, woof. Come on, man. Oink. Oh, guys, look. It's Stretchy. Hi there, Stretchy. Oh, hi there, everybody. Welcome back for another awesome video by me. And us, remember, we're part in it too. Oh yeah, and you guys too. Today, we are going to be learning even more about prisms and how many special different types of prisms there could be. Wait a minute. There are more kinds of prisms? Well, yes, of course. Because any flat two-dimensional shape could be the basis of a prism as long as the two faces that are the bases are congruent and parallel. If they are congruent and parallel, then they are the basis of the prism, and the 3D shape is called a prism. So, identify prisms. Write the shape of the base and use it to name the prism. What? How are the bases going to help us name the prisms? That's a great question, Frenchie. Prisms are actually named according to the shapes of their bases. So, when we are able to identify the shape of just one of the bases of the prism, we could be able to name the entire prism in general. Look at this prism. What do you notice about this prism? Oh, wait a second. It only has 1, 2, 3 rectangular lateral faces and 1, 2 triangular bases. Oh, so then the shape of the base is a triangle? That's right, Byron. The shape of the two bases are triangles, which means that the name of this prism is a triangular prism because it has two triangular bases. So it's a triangular prism. Oh yeah! I could see it now. That makes much more sense. Yes! Plus, if we look really closely here, one of the angles of the triangle bases is a right angle. So we could also say that this is a right triangular prism because it has a right angle. But what about this wonky-shaped one? Oh boy. This prism seems to be oddly shaped. Well, to figure out what the shape of the bases are, we need to count the number of sides. So, let's count the number of sides and see what the shape of the base is. You ready? Yes. 1, 2, 3, 4, 5, 6, 7, 8. We could double check to see if there are 8 by using a very popular method I like to use. To check if a shape has 8 sides or not, I would like to draw at least one line splitting it in half. Then, we count 4 sides here and 4 sides there. Let's see if there are 4 sides in each half. 1, 2, 3, 4. Yes, 4. 5, 6, 7, 8. That's also 4. So, 1, 2, 3, 4, 5, 6, 7, 8. Wait a second. The shape of the base must be an octagon because it has 8 sides. Okay, now let me just close my marker for a little bit. I need 2 hands to do this, so, just wait patiently. Okay, since we counted all the sides and all of the angles just to make sure, this is an octagon because it has 8 sides. 1, 2, 3, 4 dots here, and 1, 2, 3, 4 dots over there. So this is an octagonal base. Yes. So this means that, what kind of prism is it? Okay, Okay, I could figure this out. Let's see. Well, prisms are named according to their bases. So, if the base is an octagon, then is this an octagonal prism? That's correct, Lop. Hooray! Woohoo! This is an octagonal prism because it has two octagonal bases. Plus, if we double check, the two bases are not only congruent, but they are also parallel as well. So, yes, they are the bases, and this exists as a kind of prism. So this is an octagonal prism because it has two octagonal bases. But what about this one? It is not a triangle, but not an octagon either. Let's think about this shape, this bit. I think this might be an easier sides to count. So, there might be less sides on that one as opposed to this one. Let's check. 1, 2, 3, 4, 5, 6. Let's check again. And a 1, 2, 3. 1, 2, 3 on this half. 1, 2, 3 on this half. 3 plus 3 is 6. So there are 6 sides in one of the bases. This means that the base is hexagonal. So, due to the available information we have here, we could conclude that this is a hexagonal prism because this is a prism with two hexagonal bases, or basically two bases with 6-sided shapes that are both congruent and parallel. So, yep, that counts as a prism. Now, I think this is an easy one that almost all of us should be able to master. Byron, take it away. Oh yeah, this is very easy. See? There are two faces here, one on the top and one on the bottom. They are both rectangles. This and this, in other words, the front and the back faces are also rectangles, which makes 4. The left and the right are also rectangles, which makes 6. So 6 faces. The bases are rectangles because every face of a rectangular prism is a rectangle. And by the way, the name of this prism is the rectangular prism. I kind of spoiled that out, did I? Rectangular prisms are highly recognizable 3D shapes, mainly because of their rectangular faces and bases and lateral faces. So pretty much every face of a rectangular prism is rectangular. So we could say that this is a rectangular prism. Well done! But what about this one? Well, from what I could see here, this should be a rectangular prism as well. That's right, Oregon. But it could also actually be something else. It is a rectangular prism. Don't worry, you're not wrong. But it could also be something else. Look at these two letters, S and S. What do you notice about those? Oh, wait a second. The two S's show that the two adjacent side lengths are equal, which means that these two must also be equal, making the base not only a rectangle, but also a square? That's right, Stretchy! Hooray! This rectangular prism does not only have two rectangular bases, but it also has two square bases, because the two S's, you're right, represent equal adjacent sides. So guess what? Both pairs of adjacent sides are equal in length, making a square. Which means that this base must also be a square, because this must also be parallel and congruent at the same time. So these are both squares. So it is not only a rectangular prism, but it is also a square prism. It's a square prism, too. Because, as we could see here, both pairs of adjacent sides are equal in length, and all four sides are equal, which makes a square, and then another square. But for oblong rectangular lateral faces, this makes a square prism, but not a cube. Be careful over here. Don't get confused by this shockingly simple shape to learn. Although it is a cuboid, it is not a cube, because look at its faces. Not all the faces are the same shape or size, right? Yes, the four lateral faces are oblongs or rectangles that are not squares. However, the bases are rectangles that are not oblongs or rectangles that are squares. So, the two bases are squares, but the four lateral faces are oblong rectangles. So, not all of the faces are the same exact shape or are the same exact size. This does not make it a cube. However, since we do know that it is a kind of rectangular prism, it is a cuboid. It is named a cuboid mainly because it looks like a cube but elongated. Because it still has two square prisms, two square bases, excuse me. It still has two square bases like a cube would, but the lateral faces are just elongated. Because an oblong rectangle is an elongated case. An elongated oblong rectangle is not a square. So, an elongated cuboid is similarly not a cube. So, yep. It is not a cube, but it is a square prism and a rectangular prism. Because we all know that all squares are rectangles. So, it could be a rectangular base and a rectangular prism for this one. And this one, I think this one's pretty easy too. 1, 2, 3, 4, 5. Let's see. Let's double check. The method I like to use is how many on top, how many on bottom. So there must be 2 at the top and 3 at the bottom. That makes 5. So let's double check for sure. 1, 2. That's 2 on the top. 1, 2, 3. 3 on the bottom. 1, 2, 3, 4, 5. That's 5 sides. What polygon has 5 sides? A pentagon, of course. So we could say that the base is a pentagon because it has 5 sides. However, we could also say that the base is a regular pentagon because all of its sides and angles are the same exact length and measure. So, we could say that this is a regular pentagon because all of its sides are equal and all of its angles are the same measure. So the name of this prism would be a pentagonal prism. Or, since it has a regular pentagonal base, a regular pentagonal prism because it has 2 regular pentagonal bases which are congruent and parallel at the same time. So, yep, this is a pentagonal prism because it has 2 pentagonal bases. What do you notice about the name of the base and the name of the prism? Well, the most obvious pattern that I notice is that their names match up with their shapes. So if we look at the shape of the base here again at this octagonal prism, we counted the sides. 1, 2, 3, 4, 5, 6, 7, 8. That is still correct. It is still an 8-sided shape. Because all that matters is how many sides it has. So it is an octagon base. So the prism is an octagonal prism because it has 2 octagonal bases. So the prism names basically match up with the shapes of the bases. This means that a prism is named according to the shapes of their bases, which we already just learned about. So, yep. And just for short, I would like to think of this as a diagonal because, you know, this line is really diagonal. Get it? Anyway, enough about that. I'm sorry. I just love prisms. Prisms are a very complex, but somehow very interesting 3D shape to learn. This time we are going to match nets and solids. Match each net in the first column to a solid in the second column. Wow, there are a lot of nets here. It's kind of like trying to solve a puzzle. A matching puzzle. A matching puzzle. That's it. We just have to match the net to the correct three-dimensional version of itself. So, let's look over here at this first net. Now, prisms cannot be named by their nets because the nets are two-dimensional. But the nets themselves can be named based on the prism's name. So, let's take a look and see what this is. Let's count. 1, 2, 3, 4, 5, 6. 6 rectangles. Well, guys, 6 of the short sides of the 6 rectangles, or sorry, excuse me, 1, 2, 3, 4, 5, 6. Each short side of this oblong rectangle is basically each side of one of the hexagonal bases. So guess what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If we match it up over here, one side of the hexagon, one side of the oblong rectangle, 1, 2, 3, 4, 5, 6. So there are 6 lateral faces and 2 hexagonal bases. So this would be C, or matching up with this. So let's name the net of this prism. So the net of a prism cannot be named by the shapes of the lateral faces because these faces are not even the bases. Instead, the net of the prism is named based on the prism's own name. So, for example, if the prism was a pentagonal prism, then the net of that prism would be a pentagonal prism net. Simple enough. Yes. So let's just double check. 1, 2, 3, 4, 5, 6. Yep, this is a hexagonal prism, which means that its net only is a hexagonal prism net. So we could name both the prisms and their nets using special kinds of knowledge. Let's look at this one. What do you notice about these 2 triangular bases? What do you notice is different about them? Wait a second. They each have a right angle, but not all of their sides are equal. That's right, Byron. Although they both have right angles, all of their sides are actually of different measures. So guess what? This is a scalene triangular prism. What? But, how could that be? Well, Byron, it is a scalene triangular prism because if we look very, very carefully here onto one of the triangles, these 2 lines are perpendicular to each other, but this diagonal line is completely longer than the length of those 2 lines. But this line is shorter than this line, but at the same time, that line is shorter than this line. So they are basically all of different measures. This is the longest line, this is the second longest line, and this is the shortest line. The longest line of a triangle is usually diagonal, but could also be vertical or horizontal. But in this case, the longest side is the diagonal side. And these other two sides are of completely different lengths. So, a triangle that has three sides of completely different lengths is known as a scalene triangle. Plus, if we add up our knowledges together and think, are the scalene triangles the bases? Well, they are both congruent and parallel at the same time. So yes, they are bases. And a scalene triangular prism exists. That is the theory of prism existence, which is not actually real. I just made that up. That is my made-up theory of prism existence that states that although it may not look like it, if two of the prisms, sorry, not prisms, why do I keep saying prisms today? If two of the bases of a prism are congruent and parallel, then they are classified as true bases and the prism exists. So, for example, these are scalene triangles. The scalene triangles are both congruent and parallel at the same time, which means, yes, this is a scalene triangular prism, so that prism exists. Yes, based on what we know, the net of this scalene triangular prism is a scalene triangular prism net. So, 10 would be D, or this. Now, how about this one? Well, I think this is a pretty recognizable one. Everybody? Well, at least somebody. Rectangular prism, you are right. This is obviously a rectangular prism because these two are rectangles. These two are rectangles. And although these two are squares, all squares are rectangles. So these two are rectangles as well. This means that this is a rectangular prism because two of the bases are rectangles. However, it is not a square prism. Look very carefully. The bases are the shapes highlighted in blue. The squares are not highlighted in blue. So this is not a square prism. It could be, but in this case, it is not a square prism because the shapes that are highlighted in blue or the shapes that are the bases are the rectangles. So this is a rectangular prism. It could be known as a square prism, though. But in this case, this is a rectangular prism. 11 is E. So, let's review. 9 is C, 10 is D, 11 is E. Because if we look here, rectangular prism, this is a rectangular prism net. Ah, we're getting the hang of this now. But now, there are 5 squares and 2 polygonal faces. Yes, that's how you say polygonal. It's not polygonal, it's polygonal. So, let's see. Let's see if any of you could figure this out. What kind of prism is that? Doesn't even look like a prism at all. That's because it is the net of the prism. Be careful. This is not a prism, but it is the net of what the prism should look like in 2D. So, let's look at these. 1, 2, 3, 4, 5. We can assume that all of these are squares because all of the sides are equal. Let's just double check to make sure, though. Let's just see if both pairs of adjacent sides are parallel and equal, just in case we get mistaken. So, let's see. 2 pairs of adjacent sides form right angles. Yep, they are perpendicular and adjacent to each other. 1, 2, 1, 2. Yep, they are the same length, which means that all of these are squares. Because no matter which way round they are still squares. All that matters is 4 equal sides and 4 equal angles. So these are squares. Be careful here, though. The two shapes highlighted in blue are not squares, though, so be careful. Let's count the number of sides of the shapes that are highlighted in blue. 1, 2, 3, 4, 5. Again, let's check to see if it has 5 sides. 2 on top and 3 on bottom. Let's double check. 1, 2 at the top. 1, 2, 3 on the bottom. 1, 2, 3, 4, 5. Yep, this is a pentagon, which means that this 1, 2, 3, 4, 5, yes, should also be a pentagon. So everybody, at least somebody though, these two pentagons are congruent and parallel, which means that they are the bases. And if that's true, then a prism exists. But what prism exists? A pentagonal prism? That's correct! Because if the two pentagons are congruent and parallel, then they are both classified as bases. And if that is true, then the lateral faces exist, and the prism exists with a certain name, such as pentagonal prism, because it has two pentagonal bases. And if we look over here, it is named from the pentagonal prism. So this is a pentagonal prism net. Okay, so 12 is A. So 9 is C, 10 is D, 11 is E, 12 is A. Just in case you don't know what C, D, E, and A are, they are these. This is C, this is D, this is E, and this is A, which means that the last one remaining must be B. But which one is B? Oh boy, what is that thing? It looks like a walking flower or like a standing windmill. Byron! Okay. It is neither one of those, I know that. But I don't know what this is. Wait a second, I think I notice a pattern. There are 1, 2, 3, 4, 5, 6, 7, 8 oblong rectangular lateral faces on that net. Wait a second. And the two polygons highlighted in blue must have more sides than a hexagon, because there are 8 lateral faces in this prism. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. Another method I would like to use to see if it is an octagon or not is 3 on top, 3 on bottom, 2 on bottom, because 3 plus 3 is 6, and 6 plus 2 is 8. Let's double check, ladies and gents. 1, 2, 3, 3 on the top. 1, 2, 3, 3 on the bottom, and 1, 2, 2 also on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, this is an octagonal base. So guess what, guys? This is an octagonal prism because it has 2 octagonal bases. And at the same time, they are both congruent and parallel. So, a certain kind of prism, the octagonal prism that is, exists because of its octagonal bases, and that is B. Based on what we know the name of the prism now, we could say that the name of its net is known as, are you ready for it? An octagonal prism net. So, yep, this is an octagonal prism, and that is an octagonal prism net. So it is not a prism, but it is a net. Yes! So this is an octagonal prism net. This is a pentagonal prism net. This is a rectangular prism net. This is a scalene triangular prism net. And this is a hexagonal prism net. This is a pentagonal prism. This is an octagonal prism. This is a hexagonal prism. This is a right scalene triangular prism. Remember, right angles. And sides of different lengths, obviously. And a rectangular prism. Rectangular bases. Alright, that is it from us today. I hope you enjoyed this video about all other different kinds of prisms and how prisms could be named according to the shapes of their bases. But be careful, everyone. A rectangular prism is a square prism, but does not always have to be a cube, so be careful. So, since all cubes are prisms, and not all prisms are cubes, all cubes are cuboids, but not all cuboids are cubes. Be careful, guys. We will see you later in the next video. Bye, everyone! Stop sniffing!